All right. Cool. Hello, everybody. All right. Cool. Let's go ahead and get back into this. Hello, everybody. Welcome back to the channel. Hope you're having a good day so far. My name's Mike. Today we're going to be jumping back into C Programming, a Modern Approach, second edition by K.N. King. More specifically, we're going to be looking at the last couple of problems from the programming practice projects, where we left off on finishing number 8 in the last part. So part, I believe it was 5, 4, can't remember something. The previous part, we did 1 through 8, and we left off here on 9. So this session, we're gonna wrap up these last couple of programming projects today, and we'll move on. So thank you guys so much for being here and hanging out so far. Um, Hope you guys had a wonderful, if you guys are in the United States, a Thanksgiving break. I'm sure that was fun. But back to the grind here, you guys. Back to it. All right, let's go ahead and look here. Programming project number 8 in chapter 2 asks you to write a program that calculates the remaining balance on a loan after the first and second and third monthly payments. Okay, so chapter 2, programming project number 8 is this guy. Rate, amount, rate, and payment. Enter amount of loan, interest rate, enter monthly payment. Month 1 balance, month 2 balance, month 3 balance. Gotcha. So this one wants to modify the program so that it also asks the users to enter the number of payments, then displays the remaining balance after each of these payments. Okay. That doesn't seem too hard. So we'll go ahead and take our program from. Hey, Gina. How's it going? Gina Rosetown. Hold on. Oh, yeah, I did subscribe already. Nice. Hello. You're the only one in here, I think, right now. There's a couple people in here. No one's chatting. Okay, let's go ahead and get started here. So we are going to want to do, let's do this. So we enter the amount of the loan, enter the interest rate, enter monthly payments, and then enter monthly payment, how much you want to pay. Yeah, how much you paid, okay. So then we'll also make a printf statement here. And we'll just say enter loop payment loop count. Or enter like months. Months paid. Like that, I guess. Something like that. And then we'll scan F and we'll read into here a %F for a float value. And we'll read into memory, we'll say months paid, right? And we'll save into here a months paid float, right? So we have these values. Monthly rate is equal to the rate divided by this 100 float divided by 12, right? So we convert the rate and divide it by 12 from a percentage to a decimal, right? And then, so then we have loops here. So this would be how many times we're going to loop. So we take the amount less than the payment plus the amount times the monthly rate. Okay. Okay, so what we'll do is we'll get rid of this, and we'll say this. While months paid, we'll say while months, I guess we'll just say for I, we'll just use a for loop. For int I, and then while I is less than months paid, we'll say int I equals to 0, right? Less than months paid, so 0. We'll go up to months paid, and then we'll go I plus plus, right? And then let's go ahead and open up this for loop. We're going to take this. We're going to say remaining balance here, right? We're going to say remaining balance. And then, so this will loop over and remaining balance. And then we can print, it wants us to print displays the remaining balance after each of these payments. Okay, so then we're going to print f. And we'll say, we'll say percent, or say payment balance after payment, and then I'll say number, and then I'll put in %d or %f here, and we'll throw in balance after payment number. We'll throw in I plus 1, and then we're going to also throw into here is equal to a %f. Actually, this is a %d, and then this is going to be the remaining balance value, right? Oh no, that stays. Cool, so that will print out the remaining balance. And we'll do 0.2f \n, it's okay. Yeah, we'll do a \n here. Now we can get rid of this. I think if we compile this, I got a bunch of stuff here, hold on. I gotta go back. For my previous project I was working on. There we go. Okay, programming project number 9. Oh, we need to go into integrated terminal here. Let me grab this guy. Here, semicolon, my bad. And then months paid. Right. And then let's do that. Oh, months paid. And let's do // and let's run this. Enter amount of loan. So if we say the loan is $10,000, we have an interest rate of 5%, monthly payment of $500. Months paid, let's say we paid 5 months. Balance after month 1, month 2, month 3, okay. So we need to say float remaining balance equals to amount paid. And then we need to reduce, the amount less than, Yeah, amount is equal to the remaining balance. And then that will take care of that, I believe. Now we just need to decrement it down. So if we say $10,000 here with the rate of 500, oh, that's interest rate. Whoops, not 500 interest rate. No, crazy scam. Let's rerun that. Ooh, come on, trolling here. Let's run. Here, 10,000, 5%, $500 for monthly, and then we fit 5 months paid. Boom. So that's how much we went down by. I think that works. Cool. And I don't believe, okay, let's see here. Let's, okay, I am ready for some feedback on my practice problem. Don't show code, just talk through it with me. You've chosen a flow for all monetary values and rates. That works fine for practice, whatever. You correctly prompt the loan amount. Good. Here's our, you can currently doing this. Conceptually, what happens after the money? I think it's good. It's good, right? Yes. Is the order of operations the interest calculations doesn't actually reflect how long compound interest monthly, but it's a small tweak and doesn't take away from the fact your logic was correct. Okay, let's talk through how to fix. Each month, the interest applied to the current balance. So the interest plus the current balance minus the payment. Then the monthly payment reduces the balance. So it would be amount plus this less than the payment. Right. So the monthly interest rate is applied on the amount, added then to the amount, and then the payment is reduced. So if we did 10,000 here with a rate of 5 and then a $500 payment with 5 months paid, that's what we got now. So it would be this. Right, like this. Exactly. The payment is subtracted when properly reduces the monthly balance. Okay, so then let's go ahead and go back to our program from number 8 here. We probably need to fix that as well. So let's go ahead and take this line here and set it to here. And then also to here, and then to here. Then we're going to take the 1 month 1 balance and put this to amount, an amount. Take the month 2 balance, put this to amount, an amount. So that should work for that one now. Cool. Nice. That looks good. Hey, Dumb Guy Codes, I appreciate you coming in. Thanks for the comments. You're awesome, my guy. Welcome. Awesome. Let's get some tunes going here. How about my headphones were on the down end. They were dying. Are they okay now? I think so. All right, cool. Some slight tunes. Okay, so that was that one. Nice. Let's go ahead and do number 10. Okay, number 10. Programming project 9 in chapter 5 asks you to write a program that determines which of the two dates comes earlier in the calendar. Generalize the program so the user may enter any number of dates. The user will enter 000 to indicate no more dates will be entered. Okay, so programming project 9 in chapter 5. So this one asked us so dates within the same century, right? So the first year is less than the second year, or second year, first year is equal to second year, and first month is less than the second month. Got you. So let's take this into our program and let's see what we can do. So let's also take what's going on here. Okay, so just enter in dates. Okay, so enter a date. Right, this will be month. We'll say first month, second month, because we need like a. I will say a month. We'll say max month. Max day and max year. Then we'll get rid of these. Okay, so we'll say enter a date, and we'll say while 1. Right, we're going to prompt the user to enter a date. And we're going to scan that in. Actually, yeah, we'll take these back. We'll take these back as such. Okay. And then we'll get rid of this. Okay, so we're going to initially put which one is later. So if not, or sorry, I'm going to code it in Python. If month should we set these to null to start? So we'll set these to null to start for just these ones. Actually, no, sorry. These ones. Yeah, we'll set them to null. And then what I'll do is I will we'll enter a date if the month and day is equal to null, and the year is equal to null, right? We're going to set the max day equal to, or sorry, the max month equal to the month. We'll need a compound. This will be compound statements. We'll set max day equal to the day, and I'll set max year equal to the year. So in the case where they're not null, meaning that we've already established that they have values, what we're going to do is evaluate this. Else if, and we'll back this up, back that up, right? We're not going to print anything. Right? So if they're the same, well, this doesn't do anything. Okay. So we're going to say if the year provided is less than the max year, and and the year provided or the year equal to the max year, and the first year equal to the max year, and month equal to the max month, and the month max day, get rid of this, get rid of this. Okay, so if the year is less than the max year, or the year is equal to the max year and the month is less than the max month, or sorry, this is a earliest month. I'll say early for year month. Right, it's not max. It's this. Right, then we're gonna set early month is equal to the month. The early day is equal to the day. The early year is equal to the year. Let's make sure I don't have any of this. No. Okay, good. Make sure no maxes. Nice. Okay. And then make sure I have no more firsts. Good. Hey Tim, I have to get through that MIT course, and I've been lazy, my guy. I haven't gotten through it. It's just that it's just job market's so demotivating. I know like we're learning to code for ourselves and for purposes, but any hopes of future jobs are just so bleak. It's like we're so it's hard to like dive into those hard stuff. Pause. 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 Okay. Month and date. No, okay, perfect. Else if there, else, right, we'll continue. Else if, well, we'll also say else if here month equals to 0 and day equals to 0 and year equals to 0, right, we're going to break out of this. So I'll put the break out front, the first statement, and then make this an else if, right? And then at the end of this loop, I'm going to printf for %d, %d, %d is the earliest date. And we're going to put in the month, day, and year, like so. Yeah. Okay. Let's try this. Let's see what we can do. Okay, so we can't compare. So let me go back to my chapter 5 notes. Maybe it wasn't chapter 5, maybe it was chapter 4. Let's go chapter 3. Might be chapter 6. Yeah. Okay, so maybe it's all lowercase. Use of undivided clarifier, no. Hey, how's it going? Was it Mateus? No statements. Why isn't this working appropriately? I'm going to set it equal to maybe it is null. Let's look up C. Let's say in C var equal to null. In C, the expression var equal to null is used to a pointer variable var is null. I haven't really talked about pointer stuff yet here. So would I have to go like dereference this? Think about a pointer integer conversion. Oh. Right, I can't set it to null. Okay, so let's just go. The thing is that I can't. So I just need to set it to an arbitrary large value. Okay, so we just know, let's just set it to like 100. 100. 100. So then we don't even need this. Right. We'll go 11/30/2025. Oh, hold up. Okay. Right, so you can't compare null to an integer, right? So we needed to declare, I guess it's fine for this case because we know bounds on months, days, and years within the calendar. So if we just set them all to 100, that kind of solves that problem for us. So this will read while once. This should continually loop, I thought, right? No, it doesn't. Why doesn't this loop back? Oh, here, because it returns 0 in the loop here. Need that there. Let's go. Oh, right. Okay, so. Huh. Interesting. So this is still catching. Hey, Nana, how's it going? Welcome. So this is still catching that final 0, 0, 0. So here, if month is equal to this and day is equal to this and year is equal to this, we break out of the while loop, which forces us to here. Oh, sorry. This should be early, earliest, and earliest. We have it right, but it's just we have the prints wrong. So 11/30/2025, 11/20/2025, 11/10/2025, 0, 0, 0 is the earliest date. Okay, so else if the year is less than the earliest year, or the year is equal to the earliest year and the month is less than the earliest month. Why is this not actually going into this else if statement? Else if year is less than the early year. Then month is equal to month. This should have hit here that the year was equal to the early year and the month is equal to the early month, but the days were less than the earliest day, so should be setting this, right? Oh, Invented Code, that's right, people are going to be doing that. We might have to take a peek at that tomorrow. We might take a peek at it tomorrow. I've never done it before. We might have to look into it. What's going on here? Let's call printf here. Let's print out true here. If we ever hit this. No, we never hit it. Why is that? We're saving month, day, and year, which is 20. Huh. I don't want to ask for help here, but I'm kind of stuck. I'm not really seeing where my problem is. Let's go line by line. So we're setting month, day, and year equal to nothing. And we're setting early month above our limits, at our limits, max caps, okay? So if the month given and day given and year given is 0, as we break out of this loop, else if the year is less than the earliest year. Oh, I'm sorry, right? So this should be not 100. This needs to be like 9999. And day can be like 99. Or sorry, month is like 13, right? You can only have 31 days max in a month, right? So we'll say 35, 32. And year, we'll just put 9999 here. That's our problem. Good, I think we figured it out. Nice, we didn't have to go and ask for help. We are capable, boys. You are capable. Just sit with it for a little bit. Don't, So we'll go 0, 0, 0, 11, 10. Perfect. Nice. Exactly what we wanted. That is it. $2014. 1, 10, 20, 13. 1. We'll go 12. We'll say like 6, 5, 1999. Nice. Beautiful. All right. All right, let's take this guy and let's throw it into, I get some feedback. Okay, converted this one into a loop for earliest overwrite. I see exactly what you've done. You've converted your code into a loop that keeps reading dates and updates the earliest date. Whenever a smaller date comes along, let's go over it carefully. You initialize early month, early date, early year to impossible values so that any valid date will overwrite them. That's a neat trick for finding the minimum without needing a special first iteration. Reads the date by this format, which works perfectly here. Correctly provides a sentinel value to stop the loop. This is the core comparison. The logic correctly finds the earliest date. Okay, so we'll say, well, also we'll add this. Int found, or sorry, not int, sorry. Bool found is equal to false, right? We'll say that. And then we're going to say, if you find an earliest, we're going to say bool found equals to true here. There, right? So then we'll say if bool, if found, right, then we're going to print this, else we're going to print no date found. Let's get some feedback on that guy. This declares a new local variable. Oh, it does not update the found variable. Oh, I'm sorry. We just take off the declaration. We don't need to define a new variable. We're going to use our same variable. Cool. It just wants it back. Oh, it's a semicolon. Nice. Beautiful. Awesome. We were able to do that one. Let's go ahead and move on. Apply a little more time and move on. Nice. 2 more. Number 11. Write the value of the mathematical constant e. The value of the mathematical constant e can be expressed as an infinite series. E equals to 1 plus 1 divided by 1 factorial all the way. Write the program that approximates e by computing the value of this, where n is an integer entered by the user. Okay. So we're going to go include the standard io.h header file. We're going to have an int main function that has no parameters. We're going to open this bad boy up. We're going to say printf. We're going to say int e is equal to, sorry, I'll say n is equal to, yeah, we'll say int n. And then we'll say printf. And what are we going to print? We're going to print enter a number. And then we're going to leave it at that. And we're going to scanf to read that number in. I'm going to save it as an integer and read it in as n. Cool. Next, what we're going to do is we're going to have int total is equal to that. We'll say that. We're going to, I'll come up here and I'll declare it with this one. We're going to say for I int I equals to 0 while I is less than n, I plus plus. Let's open this up. So we actually do want to compute a value at n, right? So when you say less than or equal to n, we're going to do this okay, so we're going to do this is we're going to need a nested loop to handle factorial of denom, right? If you guys are in here, could you guys leave a like? I appreciate that so much. Thank you guys so much for being here and watching me complete some of these practice problems from C Programming: A Modern Approach by K.N. King. This is the second edition, Chapter 6, Programming Practice Projects. So we need a nested loop here to actually do the factorial computation. So we'll say factorial is equal to, we're going to say, sorry, int factorial is equal to we'll leave it at that. And we'll say for I for int j equals to n, right? Yeah. J is equal to n, while j is greater than 0, we're going to reduce j downward. And what we're going to do is we are going to compute factorial plus equals sorry, multiply equals to j. So 5 times 4 times 3 times. Is it sum? Is factorial sum? I forgot. factorial is multiply all the digits downward. So you take I equals to, yeah, I think it's this. So it'd be 5 times, which factorial doesn't have anything set here, right? So we need to set factorial equal to n. Set j equal to 1 less than n. And then do that. So factorial will be 5 times 4. That answer times 3, that answer times 2, that answer times 1 if factorial was n was 5. Right, so we set factorial to n. We reduce, we set j to 1 value less than n. And then we compute the factorial on all the values 1 less than n. Multiplication, right? I think that's how that does it. Hey, lovely. Lovely Tiagi, how's it going? Thanks so much for joining me. I'm gonna take this. I don't want to. No, we're not gonna do that yet. Because that'll compute a factorial. So now what we're gonna do is do just do this answer, right, of 1 over the factorial value within this outer loop. And then we're going to say this is going to be total plus equals here, like so. Total plus equals 1 over factorial. I think. And then we're going to printf, say total e approximately is equal to, and we'll insert into here the value that we want for total. Okay, so if I come back into our previous terminal and grab this guy, come into here, do 11. I'm in the wrong terminal here anyways. $11 and 11. 5, 1 to no. What we'll say is we'll insert into here the value of I. We'll say factorial I. We'll say I factorial is equal to, we'll insert into here another value. We'll say factorial, no, we'll say, sorry, I factorial. Well, you can't divide by 0. So total is just going to be one. And we're going to start n at I at 1. Right. And do that. So 1 factorial. Okay, so then hold on, we need a backslash n here. We also need one here. Okay, so this. Oh, so sorry, we need to set I. The factorial is going to be equal to the current value that we're on, and I here. There we go. 1, 2, 6, 28, 120. Yeah, that's right. Yeah. So then what we'll do, this gave an approximation of E was 5. Or sorry, of 5 was 2. So this is computing factorial appropriately. And then we have the E approximation is equal to 2 at 5. All the way up until some number n. Right, so let's say which is about 2, it floors down. So we might want to not use integer division. We might want to retain our floats, right? So let's do this. Total is a float, right, which is equal to 1.0 f. Now if we do this, to flat, we have factorial. So 1 divided by I forgot, how do you do Look at chapter 3. Oh, it might be chapter 4. Oh, here's arithmetic, yeah. This is integer division, which returns a float. Doesn't floor the value. Okay, so if we say, is this, let's try it one more time. Yeah, that's working appropriately. So the factorial is working. And we're doing 1 over the factorial for total. And we're still getting 2 floored down. Oh, let's do 1.0 f. Let's do that. There we go. And so let's make this. That's fine. So I think that this works. Let's try it. Let's get some feedback. Okay. I wrote a function for computing e given an n value. I know my factorial is working based on the printf debug. You're using a nested loop to compute factorials manually. Let's break it down and see how it can be improved. Current logic works perfectly fine for small n. Becomes tight. Use double instead of float for long. Compute factorial iteratively without nested loops. Okay, so you can say int n double for double precision. I always forget about these extra types. And then we can say factorial, which is equal to 1.0 f, right? So then we enter a number and scan it in. We say for I, well, perfect, that's fine. We say you either do this or you could do this. Factorial multiply equal by I. Well, you just take the previous factorial value and multiply it. Oh, you just carry your factorial value as you go. You don't need to recompute values you've already seen over again because you've already going over I1 through whatever, right? So you can just carry over a factorial variable and use your current value of I to multiply equal that old factorial value. Got you. That makes a lot of sense. So then what we could do is call printf. Oh, so I'll get rid of these printfs. We don't need those. And then we'll just keep the total here. Oh, like that, right? And then all this would need would be a thing like that. So this one is with a nested for loop, right? Right, you could do a nested for loop to calculate the, you can do it simply, right, carry over the previous factorial value computed on I less than 1. Cool. So then I believe that this would still do this. Oh, hold on. Undeclared factorial variable. My bad. Bug. My fault. Nice. Oop. Much cleaner and more efficient. What would 5 give you? .716. Perfect. Awesome. We got it right. All right, last one here. Yeah, these ones are a little bit more complicated, so I definitely needed to do these ones in a different stream here. Especially not while I was like tired before or something. Okay, cool. Let's do this last one. You guys are new and you're enjoying the stream. If you could leave a like, I appreciate you guys joining here so much. Appreciate you guys. I'm doing C programming and modern approach practice problems. We're working on these guys. We're on doing number 12 now. These are programming practice projects, and we're at the end of chapter 6. So next stream we'll probably jump into chapter 7. All right, last problem. Modify programming project 11 so the program continues adding terms until the current term becomes less than epsilon, where epsilon is a small floating point number entered by the user. Modify the program in project 11 Okay, so this one wants us to say adding terms until the current terms becomes less than. Modify programming project 11 so that the program continues adding terms until the current term becomes less than epsilon, where epsilon is a small floating point number. Oh, got you. So these are going to compute smaller and smaller and smaller values. So we're going to add in a second option here, printf, enter a, guess can we, epsilon, enter an epsilon, right, which is going to be right, or you say enter an epsilon, then we can say so where the number entered, so if total becomes less than the epsilon, we're going to break. And so we'll scanf into a %f and put in epsilon. Right? I think that's what we do. Go and give it a try. Let's give it a go, skis. Give it a go, skis, boys. Last one here. Bring us home. Long float. Okay, so it's LF. Oh, so we don't do a n value. Got you. So we'll just say for what was the infinite for loop? Was it for plus plus? For comma comma. Yeah, you need the placeholders. For comma comma. Okay, so we'll just do this. Factorial. We have I++ here. Broke it. Okay, so well, total, if total becomes less than, then we break out. So I guess we could say while total greater than the epsilon value. So while total is greater than epsilon, once epsilon total becomes less than epsilon, we're going to break. So right, that'll break out right away because it is 1, right? So let's say if I run this and do like 0.001. Okay, so this ran infinitely. So I increases. Well, total increases. It's not this. It's subtotal. If the subtotal is greater than, else we'll go total plus equals subtotal. I think that's what we want. Right. So double. It's 2.5. See how long we can get this to run. It's really fast. I guess he's quick. I'm not used to see the speed, huh? I am speed. Speed. I am speed. Get me in the next cars. Okay, I think that's right. So we want to compute if the subtotal that's computed for the 1 over the factorial value, the current value that we're going to add to the total is less than the epsilon. Then we go ahead and reduce, we go ahead and break. Else we'll add the subtotal to the total. Okay, so let's see here. Let's get some feedback here. Okay, so I think I have this one where we are asked to reduce to loop until we come across a computed value that is less than a really small epsilon. You're not implementing the epsilon-based approximation of E instead of a fixed n. The idea is that E is equal to 1 plus 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, all the way up until you stop adding terms, until you become smaller than some very small epsilon value. In your loop, we do this. Double subtotal 1 over factorial I plus plus. If subtotal is less than epsilon, we break, else total plus equals subtotal. The loop condition, while total greater than epsilon, is not really necessary here. What you care about is the size of the next term, so you can just use the infinite loop. Oh yeah, so it's not while total. So this would just be like while 1, because we're not checking if we're checking on the computed subtotal, right? So we could throw this expression in there, but we'd be computing the same expression twice. I mean, we could compute it, and then can we declare the variable and then use the variable in the loop if we have it? Can we do this while double? Can we do this? Can we do this inside of here? and then say, get rid of this, and then say if subtotal is greater than, does that work? Okay, so no, you cannot declare. I don't think, no, that does not work. I don't think this works, right? Let's say. You're right, the line doesn't make, it's not like a for loop. Okay, so let's back it up then and just do while one, right? We're going to compute a factorial, compute a subtotal. We'll break there. Nice. Okay. Let's get back to our feedback here. What you care about the size next term, so you can just use an infinite loop. So I guess I kind of like how it's probably typical to keep your I++ at the bottom, right? To show kind of for standard sake. Not a big deal though. What happened here? This just goes like that, right? Cool. Now this rounds to 0.10 f. So I do that 0.10 f. Kept a lot more decimals. The precision of 0.01 or point. The fixed point decimal format, the 0.10 prints 10 digits after decimal point. Okay. Okay, cool. I think that that is fine. Awesome. Cool. That one solves that guy. Cool. So we, despite that logic being incorrect, the overall problem that we wrote by ourselves was correct. That logic would never actually happen. So good on us, but or whatever. But it's better to have the infinite loop because we don't need some logic there that we don't need, right? So, but we were able to get that one, which is awesome. I'm really proud we were able to get that one. That was awesome. So we use this epsilon method to determine whether the current computed value at each kind of phase of the iteration is less than this. If it is, then you break. Else you add the subtotal that you computed, right, to the total and keep going until you get a lesser and lesser and lesser value, right? Because when I was doing the comparison to the total, that would make sense because one, we're no matter what, no matter how small these get, no, we're going to still get larger, at a very small rate with the overall total. So the only thing that's getting smaller in the expression is not n, is not the actual total, but the actual individual components computed. The factorials are even getting larger too, right? So the only thing getting smaller is the division happening of 1 over that factorial value, right? As the factorials get larger, the divisor gets larger in the denominator, making these values a lot more small as you iterate. Cool. Awesome, you guys. Thanks so much for being here. That was really cool. If you guys enjoyed this one, please leave a like. Mine was Mike, or Michael. I have a degree in human biology and a minor in chemistry, and I've been teaching myself how to code for a little over a year and a half now, and documenting it live almost every single day, or at least every time I code, at least here on the channel. If you enjoyed the stream, you could leave a thumbs up. We completed the last four programming projects from Chapter 6 of C Programming, A Modern Approach, Chapter 6 by K.N. King. We did number 9, number 10, 11, and 12. Let's just go back up to the title here. Right, C Programming, A Modern Approach. So if you guys want access to my individual notes that I had here, which are really nice to go back and reference, that I go back and look at all the time, and the actual answers to my problems for both the exercises and practice projects, please you can find those in the GitHub link down below. Feel free to star that if you do end up using it. It's a pretty great resource to have. Let's go ahead and push up our notes though, because we finished chapter 6. Finished chapter 6, programming projects, chapter 6, complete. Look, you need to put a dash in. Yeah, so these can be found on my GitHub link down below, or you can find a lot more information on the book and everything in my Discord down below. I'm currently going back through and uploading shorts of the entire reading of the book. So we do audiobook readings and reading sessions of the book, completely word for word live on the channel, where I read it aloud for our first time going through it. And I go back through and chop that up and upload it as a sole video on the channel. And now I'm going through and uploading, many parts for individual shorts of these readings, kind of like how you see people uploading like movies, I guess, like parts of movies on shorts. If you ever doom scroll and get caught up in those scroll sessions, I know I do. You'll end up watching the whole Imitation Game or the whole Unbroken or something like that while you're all sitting on the toilet. It's pretty funny. um, Got the exact same book, physical though. Awesome. That's awesome. Yeah. How do you like it so far, Alfred? I've had a lot of positive feedback regarding it. A lot of people seem to have been enjoying their reading so far of it and enjoyed working alongside me. Got a lot of great comments on the audiobooks readings that we uploaded and the shorts so far. So thank you guys so much for being here and hanging out with me tonight. I will let you guys know we did start a new project, or I started a new project offline. I'm going to introduce it on the channel maybe shortly. I'm actually moving quite quickly on this project, setting up a back end. It's kind of like really actually quite cool that like the practice that we've done on SpectroSim, on ChromaPlot, on our personal website, and all these other projects are really starting to come together because I'm actually starting to remember how to put together, a front end and back end linkage as one. There's a lot of information, so it just takes a lot of practice to go through. And so I just needed to get some repetitions, setting it up over and over and over again, linking together routes and stuff. And then once I finally gave pedantic and honest, look at, I was like, wow, this is actually really useful for like, setting up templates for receiving data types or like specifying data types for auto specification or whatever. And then also, I already work in a pretty object-oriented manner, like almost solely in my, Python projects. Like I set up classes and, set up methods for those classes to work through certain things I want to do. That's how I've always done it. I never really just throw together like just a rough script. It's always pretty organized like that. Um, and so Pydantic is actually really nice because it's very, very similar in just setting up these small classes and just specifying your data types kind of through type hinting, and you're good to go. And so it's been quite nice. So I'll introduce that on the channel some other time. You can get a little hint about it in the Discord. I kind of mentioned what it was. I did buy a domain today. I think I got a pretty cool domain for the overall topic that we're going to be building. It's going to be like a full-fledged kind of app, I think, product. And I think I have a good actual case for like a pricing model, which could be pretty cool. And I want to try to actually see if I could really, make something of this. I want to put our knowledge and code to the test and actually make a viable product, not just a simple little project that never gets used again, but something that I would use almost every single, not every single day, but every single time I do this activity. So yeah, hints all around. But if you want to get the inside scoop, it's in the Discord link down below for free. So thank you guys so much for being here and hanging out with me. Again, we completed chapter 6 today in its entirety. We were not completed in its entirety. We wrapped up chapter 6 in its entirety with the last couple of programming practice projects from chapter 6 of C Programming, a Modern Approach, second edition by K and King. You have read alouds on the channel, all that you can find. Thanks so much for being here, and I'll be back tomorrow. Let's catch up on some chats. Davey says, just tried out setting up my first third-party library in C, now learning OpenSSL. Yeah, we're going to have to get there. I do want to learn, I think it's called Port Audio or something like that. It was a C library used to get access to like the audio ports within your device and kind of like, get waveforms. So maybe we could, potentially make our own like guitar tuner or something would be kind of fun practice, and then maybe like an amplifier. Um, Thanks for coming in, Tim. I appreciate you coming in. Alfred said, I've done a bit of C though, but never through an instruction or more completed guide, such as a book. Only thing that is C89 and 99, so it's good to keep in mind. Yeah, learning x86 assembly on the side as well, although in principal assembly is fairly straightforward. Nice. Grinding. Sweet, dude. Thanks so much for coming in here and joining me today. If you could subscribe, and I'll see you guys tomorrow. And thank you guys so much for joining. Bye. Have a great night.